Now we'll see some gate problems related to group theory. Let us begin with easy question. It is given that G is a even order group. Then we have to show some element A such a way that A not equal to E. What is E? Identity element, and A square equal to E. Finally, we have to show one element which is not identity element so that A square equal to E. What is A square equal to E? Let us try to understand. A square equal to E means A star A equal to E. Then let me apply A inverse here. So that A inverse star A equal to E star. I mean left side we are applying, right? Here also we have to apply left side. A inverse star E, correct? Then A inverse star A will become E. So E star A equal to A inverse star E. But A inverse star E is what? A inverse. E star A is what? A. So A equal to A inverse. Saying A square equal to E is equal to A equal to A inverse. What is the meaning of A equal to A inverse? Element is inverse to itself. Remember that point. So finally we have to show at least one element which is non-identity element and that's inverse is itself. So we have to find out why it happens why there is such element even in even order we will see. Let us take even order as even order means what? Either 2 or 4 or 6 or 8 so on, right? Let me take 4 and explain the problem. So identity element is one element, other elements let's call A, B, C. So the question says that there is one element in these three, not this one. So that element is inverse to itself. Why sir? Simple. You know one thing, example A inverse is B, then definitely B inverse is A. So in that way, with respect to inverse relation, there is a pair, right? So that means A's inverse is B, B's inverse is A. So they are forming a pair. So we have only odd number of elements other than identity element, correct? So if every two elements become a pair, then one element will become ideal. Then what about inverse of C? Definitely it has to be because every element has inverse. Why sir? It's a group. Then where is inverse of C? It should be itself, right? So that in that way we can prove. Sir, but you explained it for 4. You can explain it for 6 also, correct? If you have 2n numbers, that's why they are even, correct? If your group size is even, the size is 2 into n. Other than identity element, the remaining elements are 2n minus 1, which is odd in number. Then according to inverse relationship, so they form pairs, correct? So whenever x comma y are inverse to each other, then we will pair it. So in that way, if you pair them, so one element will be remaining, that will become what? An inverse, an element which is inverse to itself. That's it. So this is all about the problem number 1. Let us come to the second problem. What is that? Let p comma q comma star be a semi group. That means here in the semi group there is a operator star and elements are only p comma q. Now where p star p equal to q, then we have to prove that p star q equal to q star p. Okay, prove that, otherwise show that p star q equal to q star p. What is given? Semi group. What is the extra information given? P star p equal to q. Let us begin here. P star p equal to q and to be shown is p star q equal to q star p. So we have to prove that p star q equal to q star p. With respect to p, you see q is right side here, with respect to p, q is left side here, correct? So that is the way. If you understand here also, what I do is, if I apply p here, then you get q star p. If I apply p here, you get p star q. But we have to prove that they are same. Slowly what is coming to my mind, you know, if I apply p here or p here, doesn't matter. Why? It is associative. Slowly let's connect the dots. What I do is, I apply p star p first. Okay, left side I am applying p. Then what happens? It would become p star q, right? So why I am stressing on associativity? Because it is given that semi group. Maybe we have to use the property of semi group. So otherwise, you know, why they ask to prove this in semi group? They are asking us to prove in semi group means we have to use the property of semi groups. What is the property of semi group? It is associative. Just remember it. So now come back to our this statement: p star p equal to p star q. If I same p, if I apply at right side for to p star p, so p star p equal to q star p. But we know that according to associativity, of course, otherwise directly p star p in both cases gives same, right? So if you agree that p star p is always same, then P star Q and Q star P should be same, right? So that's why definitely this is true, correct? P star Q equal to Q star P. Easily we can prove it, right? Now we'll see some more problems. Now we'll see one more gate question. Let A be the set of all non-singular matrices over real numbers. Let's start with the matrix multiplication. Then which of the following option is true? Okay. So we have to find out the correct statement. What is given? A is the set of all matrices which are non-singular. You know what is non-singular matrix? Whenever a matrix is non-singular, then we can say its determinant mod A not equal to 0. Second way we can define non-singular matrix like this. A matrix is non-singular matrix, then it has an inverse. Okay. So anyway, both are correct. But the basic definition is non-singular matrix determinant is non-zero. Now the question, which of the following statement is true? Let us begin with A. A is closed under star, but A star is not a semi-group. See, here you don't need to check whether matrices multiplication is closed or not, non-singular matrices. Why, sir? Because semi-group, monoid, group, everywhere definitely the matrix operation, that star should be closed, correct? If let's say A is not closed under star, then option D will become wrong, this will become wrong, this will become wrong, this will become wrong. So with that we realize that yes, A is closed under star, you don't need to check. But A star is not a semi-group is the thing, correct? We will see. Why A star is not a semi-group? What is semi-group? A group, an algebraic structure is called semi-group if the operation is closed. Second one, it is associative, correct? So here associative property we have to check. So associative property is what? A star B star C equal to A star B star C, correct? For matrix multiplication. A star B star C equal to A star B star C. But you already know that matrix multiplication is associative for total matrices. Now these non-singular matrices are subset. For every matrix, any matrix you take, it is associative. Then for this combination also, it is associative. You don't need to check. That's why matrix multiplication is associative. So A star is actually semi-group, but this option says that it is not semi-group. We can eliminate this option. Again, I am repeating, you don't need to check whether the matrix multiplication is closed under A or not, okay? Because then all the options will become wrong. Now, second one, A star is a semi-group. Yes, just now we discovered it, but it is not a monoid. What is the difference between semi-group and monoid? So, it's a semi-group but not monoid means probably identity element doesn't exist, correct? We will check whether this semi-group has identity element or not. Recall, what is identity element for any matrix? Let us take 2 by 2 matrix for easy understanding, okay? In 2 by 2 matrices, we know that 1001 is identity element because 1001 into any matrix A equal to A, correct? Similarly, A into 1001, you get what? A. I am using matrix properties. So that's why identity element exists, correct? So I can say that. And only thing, sir, but what if this 1001 is not singular, non-singular? What if it is not non-singular? It is non-singular, you see. What is the determinant? 1 into 1, 1 minus 0. And remember, sir, what about 3 by 3? In 3 by 3, what is the identity element? 1, 0, 0, 0, 1, 0, 0, 0, 1. Now my question, sir, directly, what if it does not belongs to this set non-singular matrices? Really, if it is not non-singular matrix, that means if it is singular, then what happens? Then in non-singular matrices, I can say there is no identity element, correct? But actually this is non-singular matrix. Why? Already I told you, this is actually upper triangle matrix, correct? Of course, it's a lower triangle also. So in upper triangle matrix, the determinant is directly the product of the diagonal, right? Product of diagonal elements. So A into B into C, here 1 into 1 into 1. Here it is 1 into 1. Similarly, for 4 by 4 also, determinant is nothing but multiplication of all the diagonal. Okay, in matrix theory you have studied it. So for every such identity element, whatever the order, so definitely determinant is non-zero. That's why identity element exists in non-singular matrices. Fine. That means what? your A comma star is monoid, but this statement says that it is not monoid, so eliminate this option. Now we'll come to this. A star is a monoid but not a group. What is the difference between monoid and group? Inverse. Maybe some element doesn't have inverse, then that cannot be a group. Now the problem is reduced to checking inverse for every element. Okay. Now we know one thing. Already I told you, every non-singular matrix will have inverse. So obviously A star is a monoid and group also. So option C is wrong. Directly come to this option D. A star is a group but not an abelian group, right? It is not abelian because matrix multiplication is not commutative. We know that, correct? So that's the reason I can easily say that option D is the correct choice. Fine. We'll see one more question. Let Z star be an algebraic structure where Z is the set of integers. Don't worry if you see algebraic structure. Whenever something is algebraic structure, you remember when we apply A star B, you get a single element. Okay. So we discussed that. Remember it. That means the operation always gives you single element. Now, star is defined by n star m equal to max of n comma m. Now, which of the following is true for Z star? So, function is given, our operator's property is given. Now, we have to identify the true statement. Let us begin with option A. Z star is a monoid. Really it is a monoid, then it should be what? First, we have to check closed property, correct? Then we have to see associativity. Third one, identity element, correct? Let us begin with closeness. You take any two, what is the domain? Set of integers. Integers means 0, plus or minus 1, plus or minus 2, so on, correct? So if you take any two elements, if I apply n star m, that means max of n comma m, that is always an element, correct? It is defined or not, we'll see. For any two elements, there will be always max, correct? Example 2 comma 100. What is max? 100. For 3 comma 1000. What is max? 1000. For minus 5 comma minus 5000. What is max? Something, right? So easily we can understand that max is defined, well defined. So it is closed and it is integer, correct? Because we are getting one of the n comma m as the answer, that is always an integer. Finally, closed properties checked. Now we'll come to associativity. Example, let's say you have three elements, okay? A star, B star, C. A star, B star, C. Second one, A star, B star, C. Just see the property. If I apply A star B first, then star C, then here A star, B star, C. What is A star B? Max of these two elements. Let us say B. Then if I apply B star C, then you will be getting max of B comma C, which let's say it is C. Okay. C is the highest one. Now here also, if you apply B star C, then first C will come. Then if you apply A star C, then again C only will come, right? Because of the order, do you get a different answer? No. Finally, out of these three, max element will come here. Out of these three, again max will come. So if you understand the logic, you can understand that associativity doesn't matter. That means the order doesn't matter. So it is associativity, correct? I mean associative. Finally, we proved that it is associative. Now we'll come to identity element. What is the property of identity element? Let's say in this Z star there is an identity element called E. What is the property of identity element? E star X or A. E star A equal to A star E equal to A. We have to prove it. Fine. But what is E star A according to the definition? Max of E comma A. Max of E comma A should be equal to A. Now think about it. What should be the identity element? Identity element is such a way that max of E comma A always A, whatever the A you take. Example, A value 100. So max of E comma 100 to be 100, what should be the E value? Anything, right? 5 or 6, anything. I assume that E value 6. But what happens is, if I apply max of E comma 3, then what happens? You don't get 3. Why? Because max of 6 comma 3 is 6. So what I want to say here is, this statement should be true for every element, not for a particular element. For 6 it is, for 100 it is correct. Which one? 6 as identity element works. But real identity element is an element which is for every combination you take, max of that E and A should give element back. But is there any such element? If and all if there is such element, it should be least, correct? Okay, what is the least element here? So least element here in 0 plus or minus 1 plus or minus 2, 0, no. Minus 1, no. Minus 2, no. Sir, but there is a least element, sir. Okay, let's really there is a least element, then what happens if you apply that max of E is, let's say, least element, least comma A always gives A, so that I can say that that least element is the identity element, that is sure. But what is least element? Example, I'm claiming that there is no least element. If you want to say that there is a least element, show me. Then some imaginary student comes into the picture, he says like this, because he always try to argue with the teacher. He says that, sir, you are wrong. What is wrong? You said there is no least element, but here there is a least element. Then I ask simply, my dear student, that's okay, what is that least element? I don't know, I am busy, sir, now, but that is, let's say, k. He says something is there, just assume it as a k. Really k is a least element. What about k minus 1? Right? Is it not smaller than k? Yes. Correct. So really k is a least, k minus should not exist. That's why immediately he will disappear. That means whenever you claim something is least element, then always I can show a smaller element than that. That means what? Your argument always will go wrong. So that's why you cannot show the least element. So that's why finally in this group there is no least element. When there is no least element, then this property cannot be. That means max of n comma m, example max of e comma m is m. This kind of property cannot be satisfied. Such element will not exist. So there is no identity element. In one line I can say that, so if and all if there is a identity element that's supposed to be least element, but there is no least element in this group, that's it. So identity element doesn't exist. Now finally I realize that this is a semi group, not monoid. Which of the following statement is true? Z star is a monoid. Wrong. Z star is an abelian group. Every abelian group is a monoid, so it is wrong. Z star is a group. If something is not a monoid, it cannot be a group. None of the above is the answer. Okay. Now we will see one more question. Consider the set sigma star of all strings over the alphabet sigma equal to 0, 1. Here sigma star to be considered. With concatenation operator, it forms dash. It does not form a group, forms a non-commutative group. Sir, what is non-commutative group? It is a group which is non-commutative. That means which is not abelian. Now third one, does not have a right identity element. What is right identity element, sir? Example, when we say that E is a right identity element, then A star E equal to A. Remember. Okay. Now E is called left identity element if E star A, that means if you apply from left side, E star A equal to A. Now, but we know only one identity element, correct? So what is the relationship between this right identity, left identity and our identity element? Our identity element generally E is right identity and left identity. Sometimes of course in in monoid only we will have identity element, correct? But sometimes we may not have identity element, but we may have right identity or left identity. But if you have a right identity but not left identity, then that is not a real identity. Okay, remember. Now we will see what is the concatenation operator and what are the various properties it has. Systematically will come. First we will check, because it is all about group, right? So see, does not form a group is my target first. First of all, I will see whether this option is correct or not. For that, concatenation is closed or not. When A is a string, B is a string, A's concatenation B always gives you a valid string, correct? So it is closed. Second, associative. When you have three strings A, B, C, order matters, like A dot B dot C, A dot B dot C. Always you ask yourself this question: A concatenation B concatenation C, A concatenation B first, after that concatenation C. Will they give different answer? No. We know that already, correct? So that's why it is associative. Now we will come to third one. What is that? Identity element. So is there any identity element? What is the property of identity element? If E is an identity element, so X concatenation E equal to E concatenation X equal to X, correct? Is there any such string? Example, X is ABC. ABC dot something equal to something dot ABC should be equal to ABC. Of course, whoever already have studied this TOC, they can easily say that it is epsilon, correct? Empty string. ABC into epsilon string, otherwise epsilon dot ABC is always ABC. Yes. So here epsilon is the left identity and right identity. So and identity, correct? So now come back. But we need to check about group, right? What is our last property? Inverse. You tell me, I have a string called, of course here we have to take zeros and ones, right? Better we take zeros and ones. 0 1 0 0 1. What is the inverse of this element? What is the meaning of inverse here? 0 1 0 0 1 concatenation something should be identity element. What is identity element? Epsilon. For this string, with what if you concatenate you get epsilon? See, whenever you concatenate something more, so then definitely the bits will not be cancelled, right? So you never get empty string, that's why. So lot of elements, I think other than epsilon, no element have this inverse element, correct? So that's why there is no inverse element for some elements, that's why it does not form a group, is correct, right? Forms a non-commutative group, wrong. It won't form a group. Then how it can form a non-commutative group? Now, doesn't have a right identity element. It has a right identity element, left identity element. So that's why option C is wrong. Forms a group. No, it won't form a group. Correct? Sorry, if epsilon is removed from the group. Okay. If I remove epsilon from the group, then even it will not have identity element. Then how can it will become group? So this is also wrong. So that's why if you know the concept, very easily we can solve the questions. Now we'll see one more question. The set 1, 2, 4, 7, 8, 11, 13, 14 is a group under multiplication modulo 15. Sir, what is multiplication modulo 15? I'll explain you. Multiplication mod n. We generally write like this. Okay. When you have two numbers a comma b, a, b multiplication modulo n is defined like a, b mod n. Already I explained you what is mod n operation in computer networks, especially network security. So in network security, I covered this operator called mod n, right? And for the people who did not attend that network security lectures yet, that is AB percentile n, that's it, very easy. Okay, multiply the two numbers and apply the remainder, that means get the remainder. Example, you have 2, you have 4, what is this 2 multiplication modulo 15 4 equal to 2 into 4 percentile 15, that's it. 8 percentile 15 is nothing but remainder 8. Example, you have 11 and 13. 11 star 13 equal to, where multiplication modulo 15. So first 11 into 13 percentile 15. So 11 13 is 130 plus 13, 143. 143 percentile 15. So 15 8 is 120, 15 9 is 135, right? Then remainder is 8. So here 8 is the remainder. That's the answer. Now you understood how that operator works. Now the question is, what is the inverse of 4 comma 7? Very easy problem. To understand inverse, first of all, inverse and identity element are connected, correct? Element A has inverse, let's say B, then A star B equal to E. That is the property of inverse, right? First you should know what is identity element here, then problem will be easy. So here identity element is 1. Why, sir? Because you see, if you apply 1 into 1 multiplication modulo 15 to, what you get? It is equal to 1 into 2 mod 15, correct? Yes. However, you take 1 and any number in this 1 to 14, the multiplication always gives less than 15, correct? Then if you apply after that mod 15, then there will not be any effect in the result. That means there will not be change in the result, correct? Because the answer is greater than 15, they are equal to 15, then only mod 15 will have any effect. So that's why it is like 1 into any normal multiplication. So in normal multiplication 1 is identity element, that's why here also it will become identity element. Example, 1 multiplication modulo 15 with 14 equal to 1 into 14 mod 15. But however, already 1 into 14 itself is less than 15, then 14 mod 15 automatically again 14 only. So 1 into x is x here, correct? So that's why 1 is identity, we realized. Now what is to be done? Identity inverse of 4, inverse of 7. Now what I do is, what is the property of inverse of 4? Inverse of 4 is, let's say, x. Then 4 multiplication modulo 15x equal to identity element, which is 1. What I do is, I will directly jump to the options. I will substitute x value here, 3 and 13, I mean 3. Then if I get 1, then only there is a possibility that it will be the correct answer. Let me directly substitute x value 3. 4 3 is a 12. Remainder with 15, 12. Is it 1? No. Then 3 is not an inverse of 4. Option A is wrong. Now we'll go to the second option. 4 into 2. Multiplication modulo 15. So 4 2 is 8. So that is not 1. Now 4. 4 multiplication modulo 15 of 4 equal to 4 4 is 16, percentile 15, which is nothing but 1. Yes. So inverse of 4 is 4. That means self inverse. Now for 7, we have to check 13. 7 cross 13 we will see with respect to 15 modulo. So 7 13 is a 91. Percentile 15, which is 15 6 is a 90. Remainder is 1. Yes. So 7 cross 13 is 1. 4 cross 4 is 1. So 4 is identity, 4 is inverse of 4, 13 is inverse of 7. So option C is the right choice. If you know the concept very easily, we can solve group theory problems especially. Okay. See this example. The set 1, 2, 3, 5, 7, 8, 9 under multiplication modulo 10 is not a group. Fine. Given below are 4 possible reasons. Which one of them is false? So let us see the option A. It is not closed. We will see first, is it the right reason or wrong reason? So closedness we know, right, how to check. So let me take two numbers. Let me apply this operator randomly because we don't have any other option. So I don't try with 1 because 1 operator x always gives x, and because x is already in the group in this set, then this after this operation also the resultant, which is same, will be in the set. So we don't need to check that. Let us take other combinations. Let me begin with 2. First 2 star 2. That means here star is nothing but multiplication modulo 10. 2 multiplication modulo 10, 2 equal to 2 2 is a 4, percentile 10. So 4 percentile 10 is 4, but 4 doesn't belongs to that set. So that means this set is not closed, correct? So sir, but what if I don't get this idea to multiply 2 and 2? Try any random combination. See, there is another combination, 7 cross 8. That means 7 multiplication modulo 10 into 8. 7 8 is a 56. 56 percentile 10, which is 6. But 6 doesn't belongs to this set. In that way, so there is no other option. We have to try all possibilities. If you are quick enough, then we can easily find out. Now finally, yes, this is not closed. So option A is the right reason, but we have to find out the false statement. This is true statement. Let us go to the option B. 2 doesn't have an inverse. We'll see. The target is 2. Let us find out whether 2 has inverse or not. So if really there is inverse, okay, then 2 multiplication modulo 10 with x should give identity element, which is 1. Right? Let us try. 2 1s are 2, not 1. 2 2s are 4, not 1. 2 3s are 6, not 1. 2 5s are 10. 10 percentile 10, remainder 0. So not 5. 2 7s are 14. 14 percentile 10, remainder 4, not 1. So 2 8s are 16, remainder 6, not 1. 2 9s are 18, remainder 8, not 1. So 2 doesn't have inverse. 2 doesn't have an inverse is true statement again. We have to find out false statement. 3 doesn't have an inverse. Try. 3 1s are 3. No. 3 2s are 6. No. 3 3s are 9. No. 3 5s are 15. Remainder is 5. No. 3 7s are 21. Yes. 21 percentile 10, which is 1. Yes. 7 is a inverse. So 3 doesn't have an inverse is false. Correct? No. 8 doesn't have an inverse. We'll see. 8 has inverse, let's say, then what it is? 8 1s are 8. No. 8 2s are 16. No. 8 3 is a 24. No, because remainder 4. 8 5 is a 40. 40% at 10, 0. No. 8 7 is a 56. Remainder 6. No. 8 8 is a 64. Remainder 4. 8 9 is a 72. Remainder 2. That means 8 doesn't have inverse, which is a true statement. Finally, C is the right choice. See this problem. For the composition table of the cyclic group shown below, what is the correct choice? So they have given a composition table of a cyclic group. You know what is cyclic group, right? Cyclic group is a group where there is a special element called G, which is a generator. That means it can generate all the possible elements if you apply this power operator, correct? That means G power 1, G square, G cube. If you keep on applying, then you can apply G power 0 also. G power 0, G power 1, G square, G cube, so on. Then it should be able to generate all elements in the group. Here elements are A, B, C, D. Our target is if something is generated, it should generate A, B, C, D. That's it. Now we'll see. Option A. A, B are generators. Really A, B are generators. First A should be generator, right? But I doubt A is not a generator because A is an identity element. So it cannot generate all the elements because there are, I will tell you the reason. See, A power 0. Obviously for any element A power 0 is E. That means identity element. Okay, fine. Whatever, I don't know what is identity element here, but it definitely generates identity element. A power 1 onwards we will see. So what is A power 1? A power 1 is nothing but, so don't get confused here. I am using E as a symbol. E is one of the element in A, B, C, D. It doesn't matter for me. Okay. So now A power 1. A. Yes. Let me write here. A, B, C, D. A got cancelled. That's why better don't start with A power 0. You can start with directly A power 1. Okay. So that we can avoid the confusion because we know what is A power 1, what is A square, so on. Of course, you know, I am not saying that A power 0 equal to E is wrong, but you have a confusion what is E here, correct? So that's why leave it. Let us begin with A power 1. A. Now A square equal to A star A. But what is A star A here? A. So that means what? Whenever A square is A, for so many reasons, this is identity element. Why? Whenever A star A equal to A, definitely A should be identity element. Already we proved it. Correct? So what, sir? Then if you apply A cube, then you cannot generate further different elements because after identity element, you cannot generate a different element. I told you in the theory. Please go through the theory if you have a doubt. Otherwise, you don't want to go to theory, but still you want to solve this problem. Apply A star A. It is nothing but A star A. Again A star A. So dead end. So there will be a loop. So finally, this A cannot be generated. Now go for, we can eliminate the option A first. Then we can eliminate option D because here also A is mentioned. Now we have only choices B, C, C, D. So what I do is, I try with option B. I select B first. Right. B power 1, B. Fresh. A, B, C, D. So B power 1 cancels B. That means B is generated. B square, B star B. What is B star B? B star B, which is A. Yes, A is generated. Now B cube equal to B star B. But associative rule holds good. That's why I can apply this one first. B star B, A star B equal to B. Yeah. So what I want to say is B cube is B, but see here already B is generated, again B is generated, then after that you cannot generate the new element. Why, sir? B power 4 is simply B cube star B, correct? But B cube is B. It is like, see, B cube and B are same, then it is like B star B, but we already tried B star B. So you get A back. Then again B back, in that way A B loop. So there is a loop between A comma B. So you never get C and D. So B cannot be a generator. So option B is wrong. We have only option C. So C comma D are generators. We'll see why C comma D are generators. Target is A B C D. Let us begin. C power 1 C. Perfect. C square, that is C star C. What is C star C? See the table. C star C B. B is gone. Now C cube equal to C star C, which is nothing but C star C is B, B star C. What is B star C? B star C, D. So D is cancelled. Now C power 4. C star, C star, C star, C. We can do so many ways because associative rule holds good. We can take C star, C star, C first. Correct? We can compute it first. Then apply star C. C star, C star, C is what? D. So we can write D star C. That is one way. Second way, you can treat like this. C star C was one number, another C star C, another number. In between there is a star. So we can apply this one first. Take C star C as a B. It is like applying B star, C star C again B, P star B. So what is D star C? D star C. Don't worry, you get same answer. D star C A. B star B A. So finally A is generated. After that what happens? Because it's identity element, so after that there will be a loop. This is about option C. So C is a generator. Similarly D will be a generator. Don't worry. If you want to know whether D is generator or not, if you are curious, you try that, because I know that D is a generator. I am not trying, but you try it. Okay. See this problem, which is asked in 2014. There are two elements x comma y in a group G star such that every element in the group can be written as product of some number of x's and some number of y's in some order. So what is the meaning of that is, like you take any number in that group G, let us call it as k. K can be written as some product of x and y's. That means like this, but not need not be in some particular order. So it can be any order. You can write like this: x star, y star, y star, x star, y star, y. So many sequences possible, right? So any possible order is fine. So in that way, every number if you try, you can write it in that form. Fine. So that is very important point. Second important point is, it is known that x star x equal to y star y equal to x star y star x star y equal to y star x star y star x equal to E. All these elements are nothing but equal to E. Fine. Now where E is the identity element? We know that the maximum number of elements in the group is the question. So what I do is, I simply try to have maximum number of elements one by one. First, definitely we have x, we have y, remember. Now the identity element we have E, but we do not know that whether E is a different element or equal to some element here x or y. So that's why let me go with a possibility that x equal to E. Then what about other elements? What I do is, because I know that whatever the elements we have in this group, definitely that can be written as this format, some x followed by some y, like this, some x, some y, some x, some y. So directly I start my reasoning from there. So I just think about a possibility of x star x, correct? This is supposed to be one element, correct? But x star x is E, that's why this cannot be a different element. In that way, I try to list out all possible two length strings with x and y, and I will check whether that is a possible number or not. Example, y star y, but y star y is not a new one. Now with x comma y, tell me one more two length string, x star y. But x star y cannot be a new element. Why? Because you assumed x equal to E, then E star y will become y. So that is not new. What about y star x? Same. What about y star x? I am repeating. Y is nothing but, y is y, x is nothing but E. Y star E, y, but already it is written. So that means no possible two length string. Let us go to three length string. Now let me go little bit quick. X star y star x, x star y star y, in that way. So just I would like to give the answer in a detailed way, so that's why it takes some time. X star y star x, but we know that x is E, then E star y star E is y. That's right. So finally in one line, whatever the string you write, all the x will be cancelled because they will become e's, then only you get y terms, correct? So if the number of y terms are 3, then that will become y. If the number of y terms are 2, y star y will become E. The number of y terms are 4, like this, then again that will become E. Now whatever I told you, right, I will explain with one example. Let's say you have x star, y star, y star, y star, x star, y. What I am saying is, however x is E, right? So E star anything will be that anything. So this will be cancelled. Now again this x will be cancelled because it is E. So here E star E will become E, that will be gone. So finally you end up with some sequence of y's, but if the sequence of y's are even number, again that will become e. That's a problem. If it is odd, it will become y, but it is covered. So finally whatever the string you write, that will become either x or y, then you end up with only two elements. But the problem, I want maximum number of elements. So if you take x equal to e, that is not leading to maximum. That's why I take x as separate, y as separate, and e as separate. Okay, already x and y different. I assume that let's say e is not equal to x, not equal to y. Because of this possibility, we have another this kind of possibility also, right? Then can we get more number of elements? We will see. Now again same listing out. So what about the next possible strings? All one length strings are gone. Two length strings, x star x, no. So we know that only x star y star x might become different elements. So x star y. Now question is, so x star y, is it a different element? What if it is equal to x? Is it possible? If x star y equal to x, then x will be cancelled, left cancellation rule. Then y equal to e, but we know that y and e are different, such a way we have selected. So x star y cannot be x. Similarly, x star y cannot be y, same reasoning. So then y will be cancelled, x will become e, but x is not e. So x star y definitely will be a different element, can be different element, right? Now what about y star x? Y star x, would it be different element? Assume that let's say it's a different element, but I am afraid y star x cannot be a different element. Why, sir? See, the problem is, if you understand this statement, slowly you will understand everything. Here the beautiful property here which is mentioned is x star x is e, means x is a inverse of x. That without understanding this property, if you go forward, then you can't solve the problem. That's why I want to use that information. Y inverse is y, that's why y star y is e. E, obviously every identity element is inverse to itself. Now what about x star y inverse? See, x star y, star x star y is e, means x star y is its own inverse. Now if y star x is a different element, what is the inverse of y star x? You see, y star x inverse is y star x, fine, everything so far is good, correct? But you see, let me apply x star y star x. What happens, we'll see. I am applying x star y star x. So x star y star y is e star x star e x star x e. So x star y and y star x, their operation is giving e, means x star y is inverse of y star x, but we know that x star y is a self inverse, then x star y should be equal to y star x. In that way, so y star x cannot be a different element, right? So finally we have this. Sir, I have a doubt. I try x star y also. Try, what happens, we'll see. Y star y is e. So x star y, you are getting x, correct? So can you infer anything with this? You cannot infer anything, okay? Fine. So finally I got 4 elements, but sir, still we can form some more elements, right? We'll try. Tell me now how to form any element. So far we have tried all 1 length, 2 length, right? Let us go for a 3 length. Tell me one 3 length string, x star x. Don't try that sequence of x, because x star x is x. It's not a different one. So that will be gone. Then you end up with, if you try that, x star x. Second one, y star x star y. If whenever you write two y's consecutively, don't try that, because that y star y will become e, then that will end up with a single letter sequence. So already that is covered. That's what I am saying. So x star e is what, x, already 1 length things are covered. So now only possibility is x star y star x star y are not reducible forms. Now x star y star x could be a different element, but no. Why? I will tell you. I am just trying out, that's it. I am trying all possibilities. If it is a different element, okay, then I just see here x star y star x, I can see here, right? That's the problem. X star y star x star y equal to x star y star x star y is given as E. That means what? This element really it's a different element. Its inverse should be y, but y is a self inverse, correct? So then x star x cannot be a different element. Similarly, y we have this one, and its inverse is x, but x has its own inverse. Then y star xy is supposed to be x, correct? Now all 3 length strings are gone. Now we'll try to understand 4 length strings. Maybe there is a 4 length string that might be a different element. Let us try that, but don't try repetition like 2x, otherwise 3x, because they all will be degenerated, otherwise reduce it to 1 length or 2 length. Already we covered them. So only possibilities will be x star y star x star y, 4 length, x star y star x star y star x. But x star y star x star y is E, y star y star x is E, correct? So 4 length is gone. Now if you go for a 5 length string, so what happens I will tell you. Try to write a 5 length string x star y star x star y star x. This is one possibility. We should write alternative x and y. Otherwise what happens? They will be cancelled. I am repeating that. So x star y whenever you write, again that will be reduced to E, then it will end up with again a 1 length string which already covered. So after that, whenever you write anything 5 length or 6 length, 7 length, that will be finally degenerated to one of them. Finally, so we are able to see only 4 elements. One is x, one is y, one is E, one is x star y, right? So that's why maximum number of elements in the group is 4. So here I have listed out systematically, right? That's it.